MEADS Flight Test 2, Mission Preview. The NATO Medium Extended Air Defense System Management Agency, NMEDSMA, MEADS International, a tri-national team formed by Lockheed Martin and MBDA, and the Material Test Directorate of White Sands Missile Range will conduct a dual intercept test of the MEADS system against a tactical ballistic missile and an air-breathing threat. The test will involve 2 lightweight MEADS launchers, a networked MEADS battle manager, 3 MEADS PAC-3 MSE certified missile rounds, and a MEADS multifunction fire control radar MFCR. For the first time, a MEADS flight test will include the UHF MEADS surveillance radar as part of the test configuration to provide target cueing to the MFCR. The test configuration will exercise all elements of the Medium Extended Air Defense System. The lightweight MEADS launcher is capable of engaging targets over a full 360 degrees. It provides high firepower with rapid reload. Its automation features reduce the number of required crew members. The MEADS launcher uses a palletized load handling and elevation system that provides for rapid full pallet reloads and elevates to a 70-degree launch position. A MEADS launcher and missile load can be transported on a C-130 and the A-400M, and 3 MEADS launchers with missiles fit on 1 C-17. In theater, MEADS launchers simply drive off, quickly set up, and are ready to engage the threat. To defeat air-breathing threats and next-generation short- and medium-range ballistic missiles and cruise missiles, the MEADS launcher carries 8 PAC-3 MSE certified missile rounds. The dominant PAC-3 MSE missile change is an improved solid rocket motor, providing greater thrust. The PAC-3 MSE is launched from a near vertical orientation to achieve 360-degree flyout capability, and it provides increased performance in both altitude and range. The MEADS Battle Manager provides the battle management, command, control, communications, computers, and intelligence for the MEADS fire unit. It controls a revolutionary network-centric open architecture that allows any combination of sensors and launchers to be organized into a single air and missile defense battle element. Through a capability called plug and fight, sensors, launchers, and other battle managers simply become nodes on the MEADS network. The multifunction fire control radar is an X-band solid-state phased array radar with an active electronically scanned array that uses element-level transmit-receive modules. It provides precision tracking and wideband discrimination and classification capabilities with improved performance in stressing clutter environments. The MFCR uses its main beam for uplink and downlink missile communications, eliminating the need for a separate communications array, and it provides a high communications burn-through capability for jamming environments. An advanced Mode 5 identification friend or foe subsystem improves non-cooperative identification and typing of aircraft. Also under development, the MEADS UHF surveillance radar provides long-range detection of low radar cross-section objects and high search efficiency over large volumes. It operates below the detection frequency of current anti-radiation missile threats. The solid-state phased array radar provides 360-degree coverage and can provide sectored surveillance in a staring mode. The surveillance radar also incorporates the advanced Mode 5 identification friend or foe subsystem. Using its 360-degree defensive capability, advanced MEADS radars, and PAC-3 MSE missile, MEADS defends up to 8 times the coverage area with far fewer system assets to significantly reduce demand for deployed personnel and equipment, which also reduces demand for airlift. In November 2012, witnessed by invited dignitaries from 3 nations, MEADS successfully completed its first intercept flight test at White Sands Missile Range. The test demonstrated an over-the-shoulder launch of the PAC-3 MSE missile against an air-breathing target attacking from behind. For the first time, the 360-degree MEADS multifunction fire control radar tracked a live target and guided a PAC-3 MSE missile to intercept. The missile performed a Meade's unique out-of-plane maneuver to destroy the target, demonstrating the launcher's 360-degree capability. The successful test fully demonstrated Meade's ability to identify, track, engage, and intercept targets attacking from any direction using a single mobile launcher. During 2013, Meade's major end items have completed a series of successful test events that demonstrated their maturity. In April, Meade's radars, separated miles apart, demonstrated target cueing and handover between the surveillance radar and MFCR at Syracuse, New York. In June, Meade's tactical battle management software successfully participated in 5 days of challenging NATO war game scenarios that demonstrated interoperability with other networked NATO air and missile defense systems. Sensor characterization tests at White Sands Missile Range conducted over the summer started on a positive note when the MFCR acquired and tracked a Lance missile flying a TBM profile in its initial test on 2 July. Now, Meade's Flight Test 2 is designed to demonstrate a first-ever dual intercept of 2 targets in opposite directions in a simultaneous engagement, a real-time stressing demonstration of Meade's 360-degree air and missile defense capabilities. The test will demonstrate 360-degree acquisition and dedicated tracking of a TBM and low-flying ABT, separated by more than 125 degrees in azimuth. Meade's generated firing solutions against a simultaneously tracked TBM and low-flying ABT required track accuracy of the rotating 360-degree MFCR, 2-launcher ripple fire against threats separated by more than 125 degrees, simultaneous MFCR to interceptor uplink-downlink functions to multiple interceptors during engagement, capability to intercept multiple threats separated by more than 125 degrees. The FT-2 test will be conducted in the TAC-2 area of White Sands Missile Range. The battle manager and all manned support trailers will be at the Meade's control site, located on the former Delta Clipper pad near the Columbia site. The Meade's launchers will be at the Meade's launch site, located on the Chaz East pad. The surveillance radar will be located at the L-825 pad near Chaz site. The MFCR will be located at a dedicated Meade sensor site at North Checker. For the FT-2 test event, 3 PAC-3 MSE missiles will be armed and expended. The battle manager's plug-and-fight software will automatically configure the MFCR and attach the Meade's launchers and the surveillance radar to form a Meade's battle element. With all radar and launcher test personnel at a safe operating distance, the battle manager will activate the system by commanding the radars and launchers to the remote mode. The battle manager operator will monitor and control the MEIs throughout the test. Upon confirmation that the Meade's test elements are initialized and operating nominally, the targets will be readied for launch. The QF-4 will be launched first and directed to its initial point at the southern end of a racetrack south of the test area. The battle manager operator will mode the surveillance radar and MFCR to operate mode. The surveillance radar will acquire a track on the QF-4 and provide this track information to the battle manager. The battle manager will use this data to create a system track and will then cue the MFCR to track the QF-4. Upon direction from the test controller, a Lance tactical ballistic missile will be launched from the north. The SR will acquire a track on the TBM as it comes into view. The battle manager will again use this data to generate a system track and will cue the MFCR to track the TBM. Upon direction from the test controller, the battle manager operator will authorize semi-automatic engagement of the tracks that correspond to the 2 targets. The Meade's battle manager will calculate an optimum engagement for each target and send launch commands to each launcher. 2 PAC-3 MSE missiles will be launched in a shoot-shoot protocol at the TBM. 1 missile will be launched at the ABT. The MFCR will establish up-down links with each missile and will guide them to intercept. During the first seconds of flight, the PAC-3 MSE may need to execute Meade's unique initial turn algorithms. From the 70-degree launch angle, the missile performs a significant out-of-plane maneuver that supports the 360-degree capability of the Meade's weapon system. The missiles will intercept and destroy the inbound targets at planned intercept points that are well away from the Meade's battle element. Following 2 previous successful flight tests, Flight Test 2 is the final planned flight test for the Meade's system under the Design and Development Program. Meade's is a cooperative tri-national development program for the United States, Germany, and Italy. It is managed by Namidzma. Lockheed Martin is the prime for the PAC-3 MSE missile, and Meade's International is the system prime.